much, Suzanne, and actually thank you for opening the door to our next speaker, Paul Terry from Phemi. We've heard both Howard and Suzanne alluded to the need for bioinformatics and the big data challenge associated with the work they're doing on individualized or personalized therapies. So, Paul, you're going to shed some light on what this means, how it's going to work.
Hi. Hello. Big data in 9 minutes. Are you ready?
Yeah.
Okay, so disclosures. I am the CEO of Phemi. I do sit on the board of Life Sciences VC. I'm also on the board of Providence Healthcare, which is interesting. I'm on the quality committee of the board. I've been doing that for 3 years now, and that allowed me to see how badly you guys access and use data. I'm also a professor at SFU looking at the big data courses. We're actually making big data engineers right now. So I'm going to do about 17 slides, 9 minutes, and at the end of it you'll know everything about big data. I have no idea what that slide's about, but I just like it, so okay, so 1990. So what happened in 1990? Cheers was the #1 show in 1990. San Francisco's won the Super Bowl, whatever that is. The thing called Stanley Cup. I'm English, I have no idea what that is. West Germany won the World Cup. But 1990 was the year that the World Wide Web HTTP was actually invented. It's not that long ago for most of us. Okay. Also, was the year that National Institute of Health, their whole data set was on 3 floppy drives. Okay. 1990, not that long ago. Now, 3 years later, they upgraded to a CD-ROM drive. Okay. And then now they have 1,600 million file drawers. Okay, just to give you a picture of the rise of data, and they haven't started on genomics yet. Okay, so our movement in data has just exploded. This is an information sport. Okay, this is a data sport that we're in. They're going to spend a lot of money trying to mess about with that data. So they just announced, as you can see, about $700 million over the next couple of years to start to mess with that data. The British also have announced about $500 million to mess with their data, and they've also announced, as people know, that they're going to sequence 100,000 people just to play with it. Okay, so here we are, we're just going to start playing with things, we're going to play with data. Kind of cool. Now this is the model of data. Now it used to be the case, we used to have a file system, remember file systems, and then for the people who are really smart have databases. And so databases require us to structure data, which is really quite a bad thing to do, but they did. All the scientists who use big data, or lots of data, never use databases. So a lot of the physicists and so forth, I started my career in physics, we didn't use databases, we just had files, big file systems, just analyze the data, we're happy with it. And then databases come along, the evil things that are databases. Now today, we are now in a new world where we can start to aggregate data, put them into what's called a big data repository, and look at all the data. This is actually a solved problem now. Okay, so although it's very fashionable, big data has become a fashion statement in the last 2 or 3 years, we've been doing big data for a long time. Google was probably the guys that did the big data, made it popular in 2000. The algorithms of big data go back as far as 1976. MapReduces were kind of basic back then. And so Google made it very popular in 2000. Why did they make it popular? Google's problem was, I want to take the whole of the internet, put it in one place, analyze it, and make shitloads of money out of it. Okay, that's what I want to do, and that's what they do. And so they literally every day go and crawl the web, bring it to one place, put it in one place. Every Google product looks at this data and generates some value. So if you want to look to the power of value of a large amount of information, just look to Google. So then, this was in 2000, everybody copied them. So Facebook copied them, LinkedIn copied them. So anybody who has a body of information and they want to make sense or make money out of it, they turn to big data. Okay, so now the relational database guys start to move into banking and transactions. If you're in a bank, relational database is good. Do anything else? It's not. So this is the model for big data. I gather information from anywhere, anything, any type, just gather it, just give it to me, and I'll suck it in and I'll store it. I then put it in a big black box of storage, and I leave it there. I don't do anything with it. At some point, I will actually bring my computers along, and I'll start messing with the data to figure something out, and generally find reports. Fairly straightforward. The problem is, when I actually present this slide to governments, and I have to several governments. They go, well, if I give all the data to people, what stops them doing anything? And you go, well, nothing. They can do anything they want. Oh my God, we're going to die. You know, it's like buying wine from a supermarket. If you get wine supermarket, people will buy it. If they buy it, they're all going to get drunk, and society will fail. Right? So this is the view of government. The society is about to fail because we're all going to get drunk on data. We're all going to put it in one place. So this is essentially the 21st century view of digital libraries. So a library is a place where you put all your information, from DVDs to books to whatever. You put it in there, you check books in, you check books out, you look for information, you look for patterns. Okay, this is where we're currently at. So the problem is that these now are called data lakes. I put all my data in the thing, and so it's quite easy to put data in the lake. The problem is getting that thimble full of information from the lake once you've actually put it in there. And that's really the challenge today. All the information I need. And often the information I need has to have semantics and context, as many of you know. We'll talk about that. So, how do you give context to data, metadata? Metadata will be the fuel of the 21st century. These people that have metadata will win. Who's old enough to remember MP3s and Winamp? Anybody remember Winamp? Oh, there you go. So what was the metadata around Winamp? It was an 8.3, remember 8.3? Microsoft file format, and you would have to get Fleetwood Mac rumors into 8 characters, and then you'd store it on your computer and go, well, what was that? I'll play it just in case. This is what we did. iTunes came along, and iTunes basically puts metadata around data. And so now I have data around the music, the record, the label, what type of genre of music it is. I have my own metadata, you know, what songs make me cry on a Friday night, I decorate those. So at any point I can dial them up and I go, oh, that's great, I can have a nice tearful evening, right? And so this is what happens. So now iTunes, of course, have revolutionized the media business because of the metadata. They can now charge for data, they can have a whole value chain for data, for records and music and so forth. This is what we're going to see in healthcare, it's what we're going to see in genomics, it's what we're going to see across public sector in the next probably 3 years. Okay, so, and some people have been very proactive at doing this. So the UK, as you know, have been very proactive. In the UK, this is interesting, they came along and they spoke to us a couple of months back. What they did was they created a scheme where all of your data, you consent for it to be used for medical research, to be sold, to anything you want. You consent. They wrote a mail to 75 million people saying, you can consent to opt out, but by default you opt in. This has caused the UK to create a great big data centre called care.data, where all the data is aggregated in one place. That's going to include genomic information, and this is going to make them probably the #1 clinical trials country in the Western world, because they have the data and people can use it. So this unlocking the data actually is now the problem. It's a people problem and a government issue. What happens when we have all this data? Then we can unlock all these engineers and scientists, you know, who are busy playing on their PlayStation, who could be solving real problems. Okay, statistics, visualization, pattern recognition. These are the next generation, next wave of our scientists coming out to help you guys actually make sense of data. 2 minutes for that. Just someone noticed that. Okay. Okay. And so a lot of universities now are starting to run big data courses. SFU runs one, where they train people specifically in these areas so that we can start to analyze the data that you can collect and you can play. Storage is cheap. I can store anything. It costs me almost nothing to store things these days. It used to cost me a lot of money. Now it doesn't matter. Compute is basically free. It used to be the case that one computer cost me money. As you know, I actually built a 100,000 processor machine in my last job, and it cost us, I think, about $20 million. It wasn't very much. All right. So big data will transform personal medicine. And the reason it will do it is it will grab all the data in one place. You heard the iTarget earlier. We're working on this now at UBC, pulling all the data from all the places into one place, solving the privacy issues, the governance issues, the security issues, aggregating the data and releasing the data to the scientists and the data scientists who can make sense of it. We still have to make sense of the data. It still needs adult supervision to be reasonable. But if we have it all in one place, we can do things like this. The end of that. I think the other one.